Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to add and subtract rational expressions. Before we do, let's go over the steps involved in this process. So the first thing you want to do in step 1 is determine the least common denominator. In step 2, you will multiply each fraction, top and bottom, by any factor missing from the least common denominator. In step 3, you will add or subtract the numerators. In step 4, you will simplify the numerator by combining like terms. Be careful to distribute the negative when subtracting. In step 5, you check to see if the final result can be simplified further. Now, these steps will make a lot more sense after we go through a couple of examples together. So if we have in problem A, x over 2 plus x over 3, the first thing we want to do is find our least common denominator. So in this problem, we need a number that both 2 and 3 will go into. So we'll use 6 because 2 will go into 6 and 3 will go into 6. All right, so we did step 1. We determined the least common denominator. In step 2, we're going to multiply each fraction, top and bottom, by any factor missing from the LCD. So in our first fraction, our denominator is 2. Now, what would I have to multiply 2 by to transform it into 6? Well, I would have to multiply it by 3. So I'm going to multiply top and bottom by 3 over 3. Now, the reason we're doing that is because 3 over 3 is equal to 1. So I haven't changed the value of the expression at all. All right. Now, our second denominator is 3. So we ask ourselves, what would I have to multiply 3 by to transform it into 6? And hopefully you said you'd have to multiply it by 2. So it would be 2 over 2. All right. So now, if I multiply 3 times x, I would get 3x over 3 times 2, which is 6. For my second fraction, I'm going to multiply x times 2 to get 2x. And then 3 times 2 is 6. Now remember, with common denominators, when you're adding fractions with common denominators, all you do is add the two numerators together. So 3x plus 2x is 5x. You do not do anything to the common denominator, so that stays 6. Now, step 5, check to see if the result can be simplified further. It cannot, so that's your final answer. All right? All right, looking at problem B, we have m over 2 minus m over 5. Pause the video and try this problem on your own. All right, welcome back. Hopefully you said that the LCD in this problem was 10. And then I looked at each denominator. My first denominator was 2. So I multiplied my first fraction by 5 over 5 because 5 times 2 would give me 10. Then I multiplied my second fraction by 2 over 2. All right, and then let's see what that gives me. This would give me 5m over 10 minus 2m over 10. All right, our next step, add and subtract the numerators. So 5m minus 2m would give me 3m over 10. Now that will not simplify, so we're going to box it in. Okay. All right, let's look at something a little bit more complex. In problem C, we have a plus 10 divided by 6 minus 2a minus 1 over 30. Now, this time when you look at your denominators, I have a 6 and a 30. Now, I need a number they'll both go into. But what I want you to notice is that 6 will go into 30 5 times. So therefore, we can use, as our LCD, we can use 30. Now, what that means is on my first fraction, I'm going to have to multiply it by 5 over 5. And the second fraction, I'm not going to have to multiply it by anything because it already has a 30. If you could think of it like this, 1 over 1. But you don't have to write that, okay? So let's multiply our first fraction. So here we're going to have to use our distributive property because we're multiplying the quantity a plus 10 times 5. So 5 times a would give me 5a. 5 times 10 would give me 50. On the bottom, 5 times 6 would give me 30. This is subtraction. All right, now on the second fraction, we're multiplying everything by 1, so it's going to stay 2a minus 1, and the denominator is already 30. Now, be very careful on subtraction. So I'm going to add in an extra step on this next part so that you'll have this in your notes, and it'll make sense when you come back and look at it. We're going to take our first numerator, 5a, plus 50, and we are subtracting the quantity 2a minus 1. That's why I want to put this in parentheses, so that if you don't put it in parentheses, one of the biggest mistakes students make is they only subtract the 2a and they forget to subtract the negative 1. Okay, so all of this would be over 30. All right, now remember, subtraction is addition of the opposite. So I can change this to plus, negative, positive, addition of the opposite. All right, so 5a minus 2a would be 3a. 50 plus 1 is 51 over 30. Now, our final result here, I'm not going to box it in because it can be simplified. All of these terms have a common factor of 3. So I'm going to divide out the 3. 3a divided by 3 is a. 51 divided by 3 is 17. And 30 divided by 3 is 10. So this is the first one we've had to simplify at the end. Okay. All right, our next problem, we have 5n plus 9 over 12 minus 2n plus 8 over 16. So our LCD, 12 will not go into 16. So what I want to do is, first of all, multiply 16 times 2 to get 32. So will both of those numbers go into 32? Well, 16 will, but 12 will not. So now I'm going to try 16 times 3, and that's 48. 12 will go into 48, 16 will go to 48. So our LCD here is going to be 48. Our LCD is going to be 48. Now, to turn 12 into a 48, I'm going to have to multiply it by 4. So 4 over 4. Okay. To turn 16 into 48, I'm going to have to multiply it by 3 over 3. All right, now we'll need our distributive property again. 4 times 5n gives me 20n. 4 times 9 gives me 36. In the denominator, 4 times 12, 48. Minus, here, distribute, 3 times 2n gives me 6n. 3 times 8 gives me 24. And on the bottom, 3 times 16 gives me 48. So again, we have a subtraction problem here, and we need to be very careful. So this is going to be 20n plus 36 minus the quantity 6n plus 24. We can't just subtract 6n. We have to subtract the 6n and the 24. And all of that's going to be over 48. So just like the last problem, please remind yourself that subtraction is the same thing as addition of the opposite. So I'm going to change this to an addition problem and change these to the opposite. Now we can combine like terms. 20n minus 6n, it'd be 14n. 36 minus 24 would be positive 12. And that's all over 48. Now, I would box that in, but I'm noticing there's a common factor here of 2. So if I divide everything by 2, I would get 7n plus 6 over 24. This is said to be in simplest form. All right. Now, in our previous examples, our denominators were all numerical. In the examples below, we will explore how to deal with denominators which are algebraic expressions. The process is exactly the same, all right? So in problem A, we have 2x minus 5 over 4x plus 4x plus 2 over 6x. So for our LCD, we need a number they'll both go into. So 4 and 6 will both go in to 12, and then we need our variable x. All right, so for our first fraction, to turn 4x into 12x, I would have to multiply it top and bottom by 3. To turn 6x into 12x, I would have to multiply by 2. All right, let's try that. So we'll distribute our 3. 3 times 2x would give us 6x. 3 times negative 5, negative 15. 3 times 4x would give me 12x, and 3 times 2 would give me 6. Oops, I forgot my denominators. 12x over 12x. All right, now, because this is addition, I can just combine like terms. So 6x plus 12x would give me 18x. Negative 15 plus 6 would give me negative 9, all over 12x. Now, I'm looking for a common factor here. I believe they'll all divide by 3. So this would give me 6x minus 3 over 4x. All right. Problem B, we have 5x over 3x minus 3 over 5x cubed. So our LCD, we need a number 3 and 5 will go into, so I will use 15. And then when you have your variables, you go with the largest power. So our LCD here is 15x cubed. So if I look at my first denominator, 3x, and I want to transform that into 5x cubed, I'm going to need to multiply by 5 over 5. And then to get the x cubed, I want to transform x into x cubed. I would have to multiply by x squared. All right. For my second fraction, to turn 5 into 15, I would need a 3. And we already have x cubed, so I'm just going to multiply by 3 over 3. All right, so now we can multiply. 5x squared times 5x would be 25x cubed. And on the bottom, 5x squared times 3x would give me 15x cubed minus. Here we have 3 times 3, which is 9. And then 3 times 5x cubed would give me 15x cubed. Now, here we're subtracting, but we're only subtracting one term, and they're not like terms. So when I write my final answer, I would write 25x cubed minus 9 over 15x cubed. All right, problem C. 3x plus 1 over 2x plus x plus 5 over x minus 3. Now, to get our common denominator here, we're just going to use both factors, 2x times x minus 3. So to turn 2x, let's see, let me highlight. To turn this denominator, 2x, into 2x, x minus 3, I would just multiply by x minus 3 over x minus 3. All right. To turn x minus 3 into 2x, x minus 3, I would be multiplying by 2x over 2x. Now, look at our first fraction. We want to multiply our numerators. X minus 3, let me write this down here where we have a little more room. I'm trying to multiply x minus 3 times 3x plus 1. So I'll use my double distributive. X times 3x gives me 3x squared. X times 1 gives me 1x. Negative 3 times 3x would give me negative 9x. Negative 3 times 1 would give me negative 3. So when I simplify that, I get 3x squared minus 8x minus 3 for my numerator. And on the bottom, never multiply out your denominators. Always keep them in factored form, and you'll see why in a minute. Let me say that again. Always keep your denominators in factored form. Okay, now we're adding here. All right, now on our second fraction, we're multiplying 2x times x plus 5. So I can just use my distributive property. So 2x times x gives me 2x squared. 2x times 5 gives me 10x. And on the bottom, again, we're keeping our denominator in factored form. Now, for addition, all we do is combine like terms. So we're going to make a new fraction where the common denominator is 2x, x minus 3. And then we just combine like terms in the numerator. So we have 3x squared plus 2x squared, 5x squared. Then we have negative 8x plus 10x, positive 2x. And then we have negative 3. Final answer. All right. Pause the video and try problem D on your own. All right, welcome back. Let's see how you did. For the LCD, I used 2x minus 3 times x plus 4. So when I looked at my first denominator, 2x minus 3, I realized I was going to have to multiply by x plus 4 over x plus 4 on this side. And on this side, I was going to have to multiply by 2x minus 3 over 2x minus 3. All right. So on the top, I'm going to use my distributive property here. 3x times x gives me 3x squared. 3x times 4 gives me 12x. And for the denominator, we're going to keep it in factored form. Do not distribute it out on the denominator. Okay. Minus. Now, on the second fraction, I'm going to have to multiply x plus 1 times 2x minus 3. So on the numerators, we do work this out. So I'm going to write it down over here. I'm multiplying x plus 1 times 2x minus 3. So x times 2x gives me 2x squared. X times negative 3 gives me negative 3x. Then we have 2x and then negative 3. So when I combine like terms, I get 2x squared. Negative 3x plus 2x is negative x, and then negative 3. And again, on the denominator, do not multiply it out. Okay. So now, because this is subtraction, we have to be very careful. Subtraction is addition of the opposite. So we're going to change this to plus, negative, plus, and plus. Then you can combine like terms. So 3x squared minus 2x squared would be 1x squared. 12x plus 1x gives you 13x. And then we have positive 3 all over our common denominator of x plus 4, 2x minus 3. And that concludes adding and subtracting rational expressions day 1.